Go for it. Today we're going to analyze three components of the standard pool shot. First, the impulse and momentum of the cue stick hitting the cue ball.
Second, the collision between the cue ball and the 8-ball. And last, the friction between the ball and the felt table.
Impulse is defined as the change in linear momentum of a body as measured by the product of the average force applied and the duration of force application.
As we just mentioned, when impulse is imparted on an object, in this case the object we will say is the cue ball, when impulse is imparted on that cue ball by the pool stick, it will result in a change in linear momentum of that cue ball. So if we're going to apply the equation that we just showed, the impulse momentum equation, which says that the impulse results in a change in momentum of the cue ball, we can plug in our arbitrary value of 175 newtons for the force of impact of the cue stick. We can say that that force is applied over a period of 0.01 seconds, and then we can also cancel out the initial velocity of the cue ball since it was not moving when it started. So by some simple math, we can see that by dividing through by the 1 kilogram over here, we can solve for the final velocity of the cue ball to be 1.75 meters per second.
The collision between two pool balls is nearly elastic, meaning that both momentum and kinetic energy are conserved.
The collision between two pool balls is nearly elastic. However, due to some sound generation, but very little, it's not completely elastic. For our purposes, however, we're going to assume it is completely elastic, meaning that both momentum and kinetic energy are conserved. Conservation of momentum is one method we can use to find the final velocity of the 8-ball. However, we're going to take you through conservation of kinetic energy. Up here is our conservation of kinetic energy equation. 1/2 mv squared for each variable, both initial and final, should be equal to each other. By plugging in the variables using that VF cue ball that we found in the last concept of 1.75 meters per second, we can then solve out and find the final velocity of the 8-ball to be 2.47 meters per second.
Friction is defined as the resistance of relative motion between two surfaces in contact with each other. In this case, the felt table exerts a small friction force that opposes the motion of the cue ball.
Lagging, which we showed in the previous clip, is a great example of how friction plays into the game of pool. Friction arises from two adjacent irregular surfaces in contact with each other. In this case of the cue ball, it is static friction as opposed to kinetic friction because the ball is rolling instead of sliding. If we were to draw a free body diagram of the cue ball, we have these three forces. The normal force, which is the reaction pair force of the weight of the cue ball, as well as the force of friction that opposes the motion of the cue ball. So if we were to plug in the values of the mass of the cue ball in terms of the normal force, and knowing that mu s between the ball and the felt table is 0.01, which is a unique quantity between two different surfaces, we can plug these into the equation of friction, and multiplying these out, including the acceleration due to gravity to include in the normal force, we can find that the force of friction is 0.0981.
So now you know how to apply the concepts of impulse, momentum, collisions, and friction to the game of pool.